Good morning, mom. Good morning, classmates. So today we're going to tackle about the kinds of refrigerant that we use in a refrigeration. So, in order to know more about the refrigerant use, we will watch a video.
Hello guys, welcome to Self-Engineer channel. We know refrigeration is cooling of space or substance. A refrigeration system has working fluid as refrigerant. But what is it? Let us discuss some common refrigerant and their properties. A refrigerant is a medium which absorbs heat from another medium which is to be cooled. For example, ice is used as refrigerant from thousands of years. Recently, we are using CFCs, HCFCs as refrigerant. Refrigerants are classified as inorganic and organic refrigerants. Inorganic refrigerants are ammonia, carbon dioxide, etc. Organic refrigerants are hydrocarbons, halocarbons, and azeotrophs. Refrigerants are also classified as primary and secondary refrigerants. Let's see one by one. Inorganic refrigerants. They are conventional refrigerants like ammonia, air, carbon dioxide, sulfur dioxide. These refrigerants are designated by R7 series. For example, R717 is ammonia. Here, R7 is followed by molecular mass of refrigerant. For ammonia, molecular mass is 17. So, it is R717. Similarly, R744 is carbon dioxide and R764 is sulfur dioxide. Average molecular mass of air is 29. Therefore, R729 is air. Let's see their properties and individual applications. Ammonia. It is toxic, colorless gas with boiling point of minus 33.3 degrees Celsius at atmospheric pressure. Look, you have to understand rationale behind learning these properties. Don't just remember them. Analyze the things. It makes you a better engineer. Like here, ammonia has a very low boiling point at atmospheric pressure. So, to evaporate it in evaporator around minus 15 degrees Celsius, we need to maintain higher pressure in evaporator. So, the compressor suction will be not in vacuum. It helps to improve operating capacity of compressor. Latent heat of vaporization of ammonia is 1315 kJ per kg at evaporation temperature of minus 15 degrees Celsius. When ammonia is mixed with air, it is flammable and explosive. Leak detection of ammonia can be done by using burning sulfur candle, which forms white ammonium sulfide fumes. Ammonia highly reacts with copper and bronze, so we generally use iron or steel in ammonia systems. We find applications of ammonia in large compression systems, cold storage, absorption systems, ice plants, and breweries. Next, carbon dioxide. It is non-toxic, non-irritating, and non-flammable gas. It has boiling point of minus 73.6 degrees Celsius at atmospheric pressure. Because of this very low boiling point, for evaporation at minus 15 degrees Celsius, we need a pressure of 20.7 bar in evaporator, and for condensation at 30 degrees Celsius, we need 70 bar pressure in condenser, which is very high. Hence, the system has to work under high pressure and it makes it less efficient. Applications of carbon dioxide as a refrigerant are found in ships. Sulfur dioxide. It is also non-flammable, non-explosive gas. It has boiling point of minus 10 degrees Celsius at atmospheric pressure. It has latent heat of vaporization about 396 kJ per kg at minus 15 degrees Celsius. It is hazardous to flowers and plants but useful for food preservation. Leak detection of SO2 gas can be done by using soap solution or by using ammonia swab. There are other natural refrigerants like air, which is used as refrigerant in aeroplanes. As you know, water or ice is also used as a refrigerant for a long time. Now, let us see organic refrigerants. The first one is hydrocarbon. Hydrocarbons are flammable and explosive, depending upon thermal properties like evaporation temperature and pressure. They are used in various industries nowadays, even by combining with other refrigerants which are known as azeotrope. Some popular hydrocarbon refrigerants are R290, propane, R600, butane, R600A, isobutane. Next, halocarbons. Halocarbons are synthetically made compounds which are also called as freons. They are generally designated as R11, R12, R13, etc. Let us see some freons which are used in HVAC industry. R11, trichloro monofluoromethane. It is non-flammable, non-toxic compound. The evaporation pressure is 0.2 bar at minus 15 degrees Celsius, whereas condenser pressure is 1.2 bar at 30 degrees Celsius. Latent heat of vaporization of R11 is 195 kJ per kg. Leak detection of R11 is done by using halide torch. It is used for flushing of system. We find applications of R11 in large centrifugal compressors. Next, R12, difluoromethane. It is colorless, odorless, non-toxic, non-corrosive, non-flammable, and it was very popular in HVAC industry. Boiling point of R12 is minus 29 degrees Celsius with evaporator pressure of 0.82 bar and condenser pressure of 6.4 bar. It is having lower latent heat of vaporization, which helps to use less sensitive regulating mechanism in system. R12 finds applications in small refrigerators. R12 leak detection can be done by halide torch. It has a white color of refrigerant cylinder. Applications of R12 are in refrigerators, freezers, AC systems which are having rotary compressors. R22, monochloro difluoromethane. It is non-toxic, non-corrosive, non-irritating, non-flammable compound. It has a boiling point of minus 41 degrees Celsius. The latent heat of vaporization of R22 is 216 kJ per kg. It has evaporator pressure of 1.92 bar and condenser pressure of 10.88 bar. Leak detection of R22 can be found by halide torch or electronic leak detector. In industry, the storage tank color for R22 is green. R22 finds application in fast freezers and low temperature applications. Next, R134A, tetrafluoroethane. It is most popular refrigerant in AC and refrigerators. It is replacement of R12 since it does not affect ozone layer. It has boiling point of minus 26.15 degrees Celsius with evaporator pressure of 1.63 bar and condensing pressure of 7.7 bar. Leak detection of R134A can be done by soap solution. We find applications of R134A in automotive AC, centrifugal chillers, and many more. Next, azeotropes. They are stable mixture of refrigerants. Their vapor phase retain identical composition over wide range of temperatures. They are usually non-flammable, low toxic, non-corrosive mixture of gas. For example, R500. It is mixture of 73.8% of R12 and 26.2% of R152. R500 has fairly constant vapor pressure curve with evaporator pressure 1.37 bar and condenser pressure of 7.78 bar. It has boiling point of minus 33 degrees Celsius. The latent heat of vaporization is 192 kJ per kg. We find applications of azeotropes in commercial systems. Refrigerants are also classified as primary and secondary refrigerants. Primary refrigerants are the one which directly used as working fluid in the system, whereas secondary refrigerants are cooled by primary refrigerant first and then they are used to cool the substance or space. The refrigerants which we have discussed earlier are primary refrigerants. Secondary refrigerants, for example, water or brine. Brine is mixture of water and salts like sodium chloride, calcium chloride. Brines are used for cooling of meat, fish, or in ice plants. So, these are commonly used refrigerants, their classification, and their applications. If you have any question, please write in comment box below. Thanks for watching.